In this video, we're going to show the main part of the proof for the Euclidean algorithm. There's very little more to show after this lemma. I'll leave it to you guys to finish up the proof. It says that if A is equal to BQ plus R, then the GCD of A and B is exactly the same as the GCD between B and R. That's mind-boggling. Nonetheless, let's prove it. This is what we do in this channel. We prove theorems after theorems, lemma after lemmas, corollary after corollary. If you like videos like that, subscribe to my channel, hit the like button, leave a comment. Okay, so the GCD of A and B, let's call it D. Let D be defined to be the GCD of A and B. Well, this implies that D divides A and D divides B. But if you look at what R equals, R is equal to A minus QB. That is, R is 1 times A plus negative Q times B. That is, R is a linear combination of A and B. Well, this implies that R divides D, because all linear combinations of A and B are multiples of D. We proved that. That's why this should be the other way around. D divides R. Okay. And for the record, D divides B. Well, if D divides both R and B, then D is a common divisor of R and B. Now I just want to show that D is the greatest common divisor of R and B. And you do that by coming up with another common divisor. Let C bigger than 0 be another common divisor of R and B. And then I have to show that that C is smaller. Okay. Now we know that we know that C divides R. C divides R and C divides B. If I can also show that C divides A, we'd be in good shape. Well, this implies that C divides any linear combination of R and B. It divides Q times B plus 1 times R. But that's A. That's A. So this implies that C divides A. And C divides B. And C divides B. But that implies, C divides B we got from here. That's why I put it in parentheses, because we already stated I just wanted it right next to C divides A. So that means that C divides any linear combination of A and B. Now, since D is equal to GCD of A and B. There exist X and Y in the integers such that D is equal to AX plus BY. Now, seed dividing A and B, seed divide any linear combination of A and B. So, seed divides AX plus BY. That is seed divides D. But that's what we wanted to show. So C is less than or equal to D because D is positive and C is positive. GCD of two numbers is always positive. Okay. So C divides D. Sorry, C is less than D. That implies that D is the greatest common divisor of A and B. No. R and B. R and B. C is the greatest common divisor. So, this implies that the GCD of A and B, which is D, is also the GCD of R and B. And that finishes the proof of this theorem. If you like to see proofs of lemmas like this or proofs of other theorems, definitely subscribe to my channel, hit the like button, leave a comment. If you have a theorem or lemma that you like for me to prove, leave it in the comment section and I will do that. But for now, see you guys in the next video, and remember, watch and learn.